Hey team, let's jump into the material for chapter 1 from Shumway Cook. This is going to be actual intro to motor control theories. We'll kind of take a look at what it really means to understand motor control in the context of being a physical therapist. So I kind of want to frame our conversation a bit. Motor control truly is this amazing window that you can use to help solve problems anytime you have a patient in particular that's more challenging. So I would say that when one is in the stage of their career where they're a PT student or a new grad, these are the things that frequently they say, oh my gosh, I feel like I don't know enough interventions. I don't know how to make things harder or easier for this particular patient. I've never heard of this diagnosis. This is a really challenging case. Feels like a lot of systems are involved. Or one of the more challenging things, a patient comes to you after having not had much health care with many things going on, and they've had a condition they're seeing you for that's been present for perhaps 10 years or more. I know even those chronic conditions can be more challenging even once you have experience under your belt. But we still want it all. There's a picture of my daughter there. I told her to go, she said she wanted a fruit snack. And I told her, go get a fruit and then we'll peel it. And she showed up with all the fruit her hands could carry. And I feel like when you're new, that's how you feel too. All right, take care of this patient. I must do all of the things. And that's a good thing, that's good. So let's build a framework so that you can, have it all. Because ultimately, what are we really doing in PT school? Everything you are learning in a classroom setting, all of the education, the training you're getting, the thinking processes you're developing, basically come down to the ability to identify a movement problem that you're trying to solve. That's a huge one. That's a really, really big one. To give you an example, I would posit that movement problems are inherently motor control problems. And two good examples, if we think about like somebody with a strength deficit, we're actually thinking about what's called a control parameter per systems theory. Control parameter being something that's kind of like the deciding factor in whether a movement changes. If we're thinking about something more in the neuro side that's like motion sickness in a car, then we could be thinking about sensory processing issues, and that's part of ecological theory. So these are just ways that you can see how your patient is having a trouble that you can make better. And from my little meme down there, a lot of times you think you've discovered what the challenge is, and as soon as you start working it, oh my gosh, there's like 15 new challenges, and theory really helps you handle that as a challenge. Okay, so as always, you can study from objectives, remembering that your exams are written from the perspective of, Dr. G is looking at these objectives. Let me find the material that's relevant to that and write questions out of it. So just framing that again. I would say that what we are also building here today is the beginnings of a structure. The structure here is a way to see the body and how it controls itself. So I'm also wanting to encourage loosely held structure. In other words, you're going to learn a variety of theories here. You may kind of think, which one is air quotes best? Loosely held structure. Being able to pivot, switch gears, and move between different perspectives is what's going to make you really, really agile as a clinician. Okay, so let's get started here. What even is motor control and why do we study it? I think we framed that, but let me just say motor control is the ability to regulate or direct the mechanisms for movement production. Why do we study it? Well, if you can really get a handle on these things, then it allows you to analyze movement, I would say. That's one of the big ones. We're going to start building that skill with y'all pretty quickly because it takes a long time to get good at it. And yet it's also one of the hallmark traits of our profession. Who's ever had a friend who's like, hey, can you look at my squat form? Or when I run, is my ankle okay? Things like that. That's skilled observation. And you have to kind of understand the system you're looking at. Otherwise, you're just going to see like little pieces of the puzzle rather than the whole thing. What's extra fun is you are joining the physical therapy profession at such an amazing juncture. The field is changing so rapidly and it's so different. I can tell you in neuro, practice is so different from even 10 years ago. Like the way we interact with motor control in our practice, wildly different. that being said, as we kind of talk about like historic and modern methods, I think our appreciation of modern and traditional, or sometimes we call it historic methods of looking at how the body moves, actually really make you a more comprehensive clinician, because obviously we want to be the most modern in our approach, but occasionally there are patients that you're using a modern approach on, it's not working, and sometimes historic methods might be handy backup tools, you know? And then I think some traditional methods are underrated, but I can tell you this for sure as a neuroclinician, motor control is truly the bedrock of probably all physical therapy and definitely neuro rehab. If you're thinking about pediatrics, oh my gosh, yes, 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 motor control all day. Okay, so let's do an odd example because I kind of want to get you in the spirit of thinking about things that are automatic and seeing the pieces of them, yeah? So this relatively boring graphic can get interesting quickly. So we're looking at the nature of movement. How is a movement produced? Well, there's an individual that's in an environment who must perform a task, right? Easy. Let's make that a little stranger. Okay, let's say you have been invited to do a presentation. It's at a very high-profile convention, and many of the leaders of your field are going to be in the audience, and this particular audience has a reputation for being, kind of judgy, and they're going to ask a lot of hard questions. So the context is the environment is stressful. The individual probably a bit anxious. The task is not so much giving a presentation, but this is a movement context. Yeah, we are PTs. But I'm going to go ahead and switch it out of PT for just a second so you're thinking in the way I want. This is actually a motor control of the mouth situation. And I'm making it that way so that you can think about this deliberately. The movement of the mouth and the muscles of speech production are actually the realm of speech therapy, yeah? But in this context, that movement might become altered by the individual and the environment relative to the task. So like that kind of stuttering, accidental mispronunciation and things like that, having trouble getting a sentence out, all of those aspects of motor speech production. There's nothing wrong with the individual's mentation or cognitive processes or the musculoskeletal components, or nothing even wrong with the environment, but the nature of everything together can generate the movement. So all this is I tried to take something kind of odd so that you're thinking about, oh, right, I don't really think about how much my tongue has to move when I'm speaking, but that's what we're going to be doing. We're going to be looking at, not tongues, I promise, no speech. Oh my gosh, so hard. Glad that's not me. We're going to be looking at the way people walk and stand and pick things up and put things down and things of that nature, okay? And it's stuff that's automatic, so it can feel easy until somebody has an impairment with it, and then that's a whole other conversation. So, our first green star slide. I will warn you that the second half of this presentation is pretty much all green stars because this is really essential stuff in the study of motor control. But this one for sure, because this is easy for me to write questions off of. Okay, a motor system. The motor system, as an idea, this introduces the idea of one of the great challenges of understanding how a body moves and controls itself. So we perform a functional movement, but we often do this with multiple parts of our body. And so each part of the body, different joints, represent a motor control or biomechanics concept called a degree of freedom. And that's kind of the joint that can move. So for example, right now, I want you to take your arm and reach out and touch something in front of you. So right now my keyboard's in front of me. So I'm going to reach out my arm, extending the elbow, and touch it with my index finger and then bring my arm back. When I did that, I needed a stable trunk and the use of my shoulder, elbow, wrist, and fingers. Each one of those represents a different joint as well as a firm base of support. I'm seated right now. So all of those joints represent a degree of freedom. My wrist can flex or extend, it can deviate. My elbow can extend or flex, or it can move in different way, all kinds of options, yes? So all this is to say that the ability to control all of those systems is a degree of freedom problem, okay? So how do I reach out and touch my keyboard without my hand crashing into it or falling onto the desk that my keyboard is on, or instead like raising my hand in class type motion, like in shoulder flexion, things like that. So we can kind of already get a sense that degrees of freedom offers a really good window into the idea of progression regression. So if someone is having trouble with control, you can reduce a degree of freedom. In other words, have them not move one joint on a limb, and that can improve things. Sensory perceptual systems. Oh goodness. The position of the body in space, essential to control functional movement. Perception is not the sensing, it's the processing of the sensing, yeah? So for example, you can touch something, but that might not like mean anything, you know? Sensory information has to get processed so that it is actually perceived. And this information gives you a framework in which, okay, where's my body in space? What is the environment? Gives you the ability to see what is and isn't working in terms of movement. A lot of proprioception here. So that's always very important. And a good example of altering this, I would say one of my favorites is when, have you seen those videos of a dog that gets shoes for the first time and they walk in that kind of bizarre fashion? That's kind of funny in a way, and they look like really confused, and the shoes might even have like really good like rubber grip or something if the dog is like slipping. So that's a good example of sensory perceptual systems and their role in a functional movement, which for the dog is just walking. Okay, cognition. So this is all the things that make us human, right? Obviously essential to motor control, and all those different attributes there count as what we consider cognitive, so attention, planning, and so forth. I would say while PTs don't necessarily interact with these as much, like with deliberation, we do, but sometimes not right off the bat, you know, we're more motor control motor systems or sensory systems. I would say it's more so that it's in our context. So cognition drops in the context of high pain, high stress, high fatigue, novel situations, all of those things combined. I would say a classic example is a patient who has something that requires hospitalization and their day-night cycle is off, everything is off, they're in pain and they're terrified and they're tired because in the hospital, it wake you up every few hours to do various vitals and lab work. So in that context, and then let's layer on like a neuro condition on top of that, yeah, that's a huge hit to a cognitive system. I've treated patients whose baseline IQ is probably sky high and they cannot figure out how to put on their socks, you know? So that's kind of the aspect of cognitive there. I mean, I can teach you how to sit to stand all you want, but if you can't even focus on straightening your knees, then we have to adapt as the clinician. Okay, so let's kick in here. Task constraints on movement. So what is a task constraint? A task constraint is like an aspect of the movement that can kind of allow you to describe it. So table 1.1 has a good description of that, but we're going to dig in as well. So the type of task has a lot of impact on what parts of the brain are working as well as the peripheral nervous system. So for example, you can have an open movement versus a closed movement. So that's a predictable environment versus an unpredictable environment. I would say a nice example of that is running on a treadmill versus running on the beach, like with sand. And the waves are crashing into your feet. So that's kind of the idea of the environment playing a role in predictability. So that's a task constraint, okay? It's not so much the movement itself, it's where you're doing the movement. An environmental constraint would be something else that changes the movement, like a regulatory feature. So in the context of that walking, I would say the fact that sand is going to depress, it's going to squish down, that's a regulatory feature of the environment, okay? So the unpredictable nature of the beach is more open. The squishiness of sand is regulatory, okay? I told you we're going to be looking at things that seem simple. We're going to pull them apart, okay? We're being deliberate here. As well as like, imagine if there's ice and you're trying to get to your vehicle and the driveway's got a little bit of a slant to it. That's a regulatory feature of the environment. It's going to change the way you move. Non-regulatory environment, it doesn't necessarily have something to do with like the physical aspects of it, but it's more something general. So the usual examples there are distractions such as noise. So performing, it's the classic when somebody's trying to shoot a free throw and everybody behind them is making noise and trying to be distracting, right? So that's a non-regulatory feature of an environment. Okay, so now we're going to move over into theories of motor control, and we'll do that on the next part.